Okay, all right, so now we talked about this has 250 pounds of pressure to start off. It has acetylene, acetone that turns into acetylene into a vapor. If you turn this valve to anything greater than 15 psi, it's not going to allow enough time for the liquid to turn into a vapor. So what happens is the liquid will end up coming out, and we will use, instead of a vapor, a gas, we'll end up burning liquid, which is not a good thing. It can cause an explosion. So we never want this to be turned any greater than 7. On average, we can get up to 10, but keep it below 10, ideally at 7. Anything over 15 is going to get you hurt. We always want to keep this bottle upright because it allows that liquid to stay at the bottom, therefore allowing it time to turn into a vapor. If it is ever laid over, set it back up before use. Allow it to sit. I recommend 24 hours. There's some guys that do 2, 6, 10, 12 hours. But on the safe side, we're going to keep it at 24 hours upright before use. Okay, so we've got that down. We've got it set. All right, step 7. Slowly turn oxygen bottle on all the way. Set gauge to 21 psi. Do not stand in front of gauges. Okay, this is the main bottle that we don't want to stand in front of. This bottle has 2,400 pounds of pressure, and this is oxygen. Can anybody tell me if oxygen burns or not? If you answered no, you answered correctly. Okay, oxygen is not a fuel. If oxygen burnt right now, the atmosphere would be on fire. Okay, now does oxygen help anything burn? Absolutely. How many of you have been on a camp out and you built a campfire and you're trying to get your campfire to go and you bend over and you start blowing on it? What happens? Fire gets bigger. So you're adding more oxygen to that campfire. So oxygen is not a fuel, but it will help a fuel burn greater. Okay, so this has 2,400 pounds of pressure on it in this whole entire bottle. And this bottle is hollow all the way on the inside. Consequently, let me discuss this right now. These bottles are thick steel. This one's probably about 3/8 to ½ inch thick. This one's a good 1/4 inch thick. You never want to grind, cut, drop, scar, damage these bottles in any way. These valves right here are just pressed in. Okay, they're not welded. So if you have your cap on, you put your cap on this thing and you're transporting it or moving it, and you see this cap has holes in it. I've known guys to put chains in this and pick the whole bottle up. Not good. This thing is pressed inside here with pressure. You get enough pressure pulling on it, it will come undone. Okay, 2,400 pounds of pressure, all inside this bottle. That's 2,400 pounds of pressure per square inch. So every square inch, there's 2,400 pounds. Just imagine if you had 2,400 pounds standing right above you, you holding that up, you'd get crushed. Well, just imagine on every inch in the side of this thing, there's 2,400 pounds. So you equate all of that coming out of this little valve, that equals 4 million pounds of thrust. Some of you heard me say this before, but it's a good analogy. The space shuttle, to get the space shuttle to take off, it takes 3 million pounds of thrust to lift that puppy and put it into orbit. That's 3 million. This has 4 million. So what do you think that's going to do to you if you damage this in any way? It won't be pretty. So we always want to be careful with this. Open this slowly, as I'm going to do here. And once you get it open, then you can open it fast. Once that initial opens fast. And the reason we do that is because inside this gauge, there is a rubber diaphragm. And if there's a piece of trash or a little grain of salt or sand and it goes in there and all that pressure's coming through here and hits that rubber diaphragm, it can cause this T-handle to pop out. That's why we have these gauges turned up. For some odd reason, if there's a problem, we'd rather it go up and over rather than if I was standing in front of it and it was facing me, rather than it coming to me, because that would go right through me and probably right through that wall. Okay, so we have this turned on. Same thing. Outside numbers, we ignore. We go with the inside numbers, and we want to turn it to 21. There's 20 there. So I'm going to turn that to 21. Turn it slow. You can't turn them backwards. You can't back it off unless you bleed the lines. Okay. Now if you look over here, this tells you how much pressure is on the bottle, inside numbers. Right now we're about 16, 1700 psi in this bottle now. Okay. So we're set up there. We're good to go. Okay, number 8. Turn bottom oxygen valve on torch all the way on. That's this bottom valve here. We're going to turn it on very slowly. And when we get it open, we're just going to snug it. These are needle valves. They're not colored lines. Do I?
Show the colored lines.
Okay, yeah, that's a good point. These lines, this is green. This is your oxygen, your oxidizer. This is red. This is your fuel. Acetylene here, oxygen here. And if you don't know how to do it, just follow it. Follow the hose. Green comes up in here and it goes, that's your oxygen. It even has an O there for oxygen and an F there for fuel. Red goes to fuel, green goes to oxygen. So we want to open this valve up all the way. Anytime you're dealing with these valves, you just want to snug them. You don't want them to be too tight. They're needle valves, they're very sensitive. If you over tighten them, you'll damage them. So make it slow and snug them. Never put a gorilla tight on them. Okay. With striker in one hand and torch in the other hand, turn acetylene valve on torch 1/4 to 1/2 turn and light torch. Okay, so here's my striker. I've got this on. I know this is off. This is off.